This last set I picked out because these are some special cases we need to be aware of. And what I mean by special cases is, as we do these problems, something weird is going to kind of happen here. So I've got two to just kind of explain this. All right, so 2x plus 4 equals 2x minus 3. And so first thing would be to simplify, but I don't see any like terms. I don't see any parentheses, so I move to step 2. I don't like variables on both sides. So let's just say, for example, I focused in on this one. I'm going to get rid of this 2x by subtracting the entire thing away. What I do to one side, I do it to the other side of the equal sign. Now here's where the weird thing happens. Minus 3 gets recopied, equal sign gets recopied, the positive 4 gets recopied, but then over here, 2x minus 2x, that's 0, and this also cancels out. And so I run into this problem that the variable that I was solving for disappeared. So x disappeared. Now, not only did my variable disappear, that what was left over doesn't even make sense. And so it's because of those two things that we run into this special case, that one, my variable that I was trying to solve for disappeared, and the remaining equation, 4 equals negative 3, isn't even mathematically valid. What this means is that this problem was bogus to begin with, that somebody created an equation that was unsolvable. So what we would write here is no solution. This problem had no solution to begin with, and so these are the two criteria that tell us that in the process of your work, the variable that you were solving for disappears, and then whatever's left over doesn't make any kind of sense at all. And this means there was no solution to begin with, and that's what you write for your answer. Now, which is a little bit different from this one. And just ignore my extra parentheses here. This shouldn't be here. All right, so in this problem, let's go through our steps again. Let's just assume it's a normal problem. So first thing is we clean things up. I see some distributive property here we could do. And I'm going to get a half times 6t, that's 3t, minus a half times 4 is 2. And let's copy the right-hand side down. Okay, and I think some people start to see it already, but let's keep going. So the next thing here is I don't like variables on both sides. So let's assume I'm getting rid of this one, 3t. So I subtract away 3t, subtract away 3t. And the same thing that happened up here happens here. I purposely got rid of this one, but then in the process of getting rid of that 3t, this set disappeared also, and I get this. So once again, the variable that I was solving for disappeared. Okay, but notice the difference here, that this time the leftovers make sense. Okay, even though it's not the answer we were looking for, that t disappeared, and negative 2 does equal negative 2. All right, and so what this means is not no solution. In fact, it means almost the opposite, that I could have picked t to be anything I wanted it to be. That there's infinitely many solutions that I could have chosen here. And in fact, I'm going to show this to you. So let's say, just off the top of my head, I pick 5. Well, 6 times 5 is 30. 30 minus 4 is 26. Half of 26 is 13. If I put 5 in over here, 3 times 5 is 15. 15 minus 2 is 13. 13 equals 13. But then let's say I pick a different number. Let's say I pick 2. Well, 6 times 2 is 12. 12 minus 4 is 8. Half of 8 is 4. If I do that over here, 3 times 2 is 6. 6 minus 2 is 4. 4 equals 4. And so basically what happened here was that even though it didn't look like it initially, the left side of the equation and the right side of the equation were identical. And so it didn't matter what t was. T could be anything you want it to be. It could be 0, it could be a million, it could be negative 2.8. No matter what, it's going to work because the left side and the right side, the math is exactly the same. Okay, and so once again is that you do your work up to this point and you're looking for, again, two things. That the variable that you were solving for disappeared, just like it did up here, But what's different about this scenario is that what's left over makes mathematical sense. -2 did equal -2, and so that's how I know it's infinitely many solutions. I can pick t to be whatever I want it to be.